Hello, Mr. Colati here. Today we're going to begin looking at bivariate analysis. That's where we compare two different variables and how they're related. We're going to use something called the line of best fit. You definitely know what a line of best fit is. You did this in grade 9. So this is something that we're going to go really quickly through because you've done it before, and we're going to show you more effective ways how to do it in later sections. But the back end of this section, so the back page here, will have some applications I want you to make sure you take a look at. Because sometimes interpreting the line of best fit is something that you'll see on an IB test. So below we have the number of, we have some data. This is the number of speed cameras and the number of car accidents. So I have all this data. That's my first variable. That's my second variable. It doesn't look very useful like this. But I'm going to graph it. I'm going to present the data in the graph. So I put my number of speed cameras as the X coordinates and my number of accidents in the 7-day period on the Y coordinate, and I graph each of these points. And what do I see? Well, we talked about correlation yesterday. What's the correlation here? Well, it is going downward, so it's negative. Is it very strong? It's strong, but the dots aren't in a perfect line. They're spread out a little bit. So I would say it's, if I had to use a word, I'd say it was moderate. And it's looks like a line, so it'd be a linear correlation. So a negative, moderate, linear correlation. What does that mean? That means that as you have more and more speed cameras around the city, the number of accidents goes down. This is some statistics that people would cite then, oh, we should buy more speed cameras because it makes people drive slower. As you know, we have a new speed camera outside of our school, and I can tell you, I definitely drive a lot slower as I'm driving around that speed camera. So the way we can model this data, remember this is real world data, it's a bunch of dots, it's not perfect. But when we model things in the math world, we want to use some sort of equation, some sort of line so that we can make predictions. The way we do this is we draw a line of best fit, which is also called, aka, a trend line. This is the term you would see, especially if you use Microsoft Excel, and also known as a regression line. This is the kind of big kid word we're going to be using in IB math, the regression line, not the line of best fit. Once we have the equation of a line, we can use it to make predictions. Interpolation, or interpolate, which is when you make predictions within the data, and extrapolate, which is when you make predictions beyond the given data. We'll come back to that. So how do we figure out the line of best fit? Well, in grade 9, we learned that we can draw it by eye. As long as we try to make sure that there are the same number of points above and below the line. So drawing the line of best fit, what we found in grade 9, it wasn't super accurate, right? We would draw, I need to get my ruler. I need to draw a line that goes through just to balance the data. So here I have 4 points and then 4 points here. Maybe I'll make it something like that. So try to even it out. And you do your best, right, to draw a line. Okay. Do we have an outlier in this data? I thought I had an outlier, which was around 20 something, 28. No, I guess my data is all amazing. Okay. Sorry. So this is my line of best fit. It's okay. But your line of best fit might be slightly different because when you're doing something by eye, you can't guarantee that everyone's going to have the same answer. But regardless, once you have the line of best fit, you can figure out the slope, you can figure out the equation of the line, then you can use it to make predictions. So if I want to know, hey, how many car accidents am I going to have if I have 25 speed cameras, I can sub it into my equation and figure out the corresponding number of accidents. That's called interpolation. Now, if you want to know, well, what's going to be the number of accidents if I have 50 cameras, or sorry, say 35 cameras, That's extrapolation, because my data only goes from 3 to 27. You know, it doesn't go to 30 speed cameras or beyond. So you're making predictions. It's a little bit loosey-goosey because that's, you know, who knows what happens to the data after 30. It could go up or down. It could be completely different. So it's dangerous to go beyond the given data. And especially if you go very far beyond. Like if I want to know, okay, well, how many accidents am I going to have if there are 50 speed cameras? I would say to you, you can't use this data to do that because it's too much of an extrapolation. Okay, and let's continue. So we have, okay, so we don't like this line of best fit. It's too inaccurate. So a better line of best fit would pass through a calculated mean point x bar, y bar, which is made up of the mean of the x values and y values. So for our data, x bar is going to be the mean of all the x data, so I have to add up all the x coordinates or x data and divide by the number of pieces of data. So my x values are what, 7 plus 15 plus 20 plus 3 plus 16 divided by 1, 2, 3, 4, 5, 6, 7, 8 pieces of data. If I type that into my calculator, 7 plus 15 plus 20 plus 3 plus 16 plus 17 plus 28 plus 17 divided by 8 gives me 15.375. Similarly, y bar is equal to the, oh boy, the sum of all the y's divided by n, so I get 48 plus 35 plus 31 plus 52 divided by 8. Type that in my calculator, and I get 37.375. Okay, let's turn the page. Okay, so now that I have the mean point, I can find the equation of, or the line of best fit using that mean point and any second point in the data. So consider what I found was 15.3 and 37.3. So I'm going to graph that point, so that's 15.337, so it's somewhere around here, maybe. So that is my x bar, y bar. So that's not enough to make it a line of best fit. You have to choose one other arbitrary point in order to draw the line. So I could choose this point, this point. Let's choose a faraway point. So there's my new line of best fit. You can see, is it as good as my other one? No, but the nice thing is it uses a central point, and then it's a little more reliable. Like you could reproduce it because someone else could do my calculations. Let's find the equation of that line. It should be, again, pretty straightforward. So we can use the mean point, 15.375, comma 37.375, and another point, say we'll use that first point, 352. So to find the equation of the line between these 2 points, you guys did this in grade 9. First we need the slope. We use the slope formula, y2 minus y1, x2 minus x1. I end up with 52 minus 37.375 over 3 minus 15.375. And I type that into my calculator, so I get 52 minus 37.375 divided by 3 minus 15.375. Okay, that gives me a slope of negative 1.182. Okay, so a negative slope, which is what I expected. So now to find the equation of the line, I sub m and that other point, 352, into the equation y equals mx plus b. So then you have 52 as my y is equal to negative 1.182 times the x, which is 3, plus b. And now we're not going to show you this because you've done it before, but you would find out that b is equal to 55.546. Therefore, y is equal to negative 1.18x plus 55.5. Be really careful that even though you write an equation, this should still be 3 sig figs. And this should be 3 sig figs. So be careful with that in your final answer. Now, this process of finding the line of best fit using the mean point is better because you guys could reproduce it. We would both get the same answer, but it's not great. And we actually will find in the next section, we can do this with our calculator a lot more effectively. So even though I'm showing you this, this is not really ever used in an IB test or exam. So it's just kind of a backgrounder. That's why I don't want you to dwell on this too much, but we should understand it. This is the part that I want you to pay attention to and be really careful with, because these questions that are coming up do come up on IB tests. The first thing to note is this line of best fit, y in terms of x. This allows us to make predictions for y in terms of if I know the number of x, the number of speed cameras. So if you want to plug in x equals 5, it'll spit out the number of accidents. You cannot go backwards. That's really important. When you make a line of best fit using statistics, even if you use your calculator, this line of best fit cannot be used to predict x from y. You cannot do that. You can't sub in y. You'd have to collect the data, put it on axes, and make a new line of best fit. And we'll show you how to do that in a few days. This is a really important point, and this has been stressed in the new IB math curriculum. It doesn't work out just because of the way the data is arranged. It's not symmetrical. So no, please don't fall for that trap. So now let's use our model that we just made to make some predictions. How many predicted accidents for 25 cameras? Okay, well, that means I use my model, so I sub in x equals 25. So y then is negative 1.18 times 25 plus 55.5. So it's negative 1.18 times 25 plus 55.5. That gives me 26. So there are 26 accidents. That's my prediction based on my model. Okay, how many predicted accidents would you expect for 50 cameras? Well, 50 cameras, like I told you, that's way beyond my data, right? We only had data that went from 3 to 28 cameras. So 50, that's a little too far of an extrapolation. So if someone asked you to do this, we would say we can't. We cannot extrapolate for an x value that is so far beyond the data used for our model. It would be fake news. It wouldn't be right. It would be like trying to, the weatherman using his weather model to try to predict the weather for next summer, right? It'd be very far of an extrapolation. Weather person, sorry. How many speed cameras would you expect if the number of accidents is 44? So that would mean y is 44, right? Well, like I just told you, very important, you cannot sub in y equals 44 and get an x. Not from this model. You'd have to make a new model. So this is big. We cannot use our model to predict x from y. We cannot go backwards. Now we have a IB keyword here, interpret, which means I want you to tell me about what the slope means, or explain what it is. Not tell me what the slope is. Interpret means explain the number. So that number is negative 1.18. So what does that mean? Well, that means that for every time I increase the speed cameras by 1, the number of accidents goes down by negative 1.18. That's my interpretation. For every increase in the number of speed cameras there is a decrease of 1.18 accidents. So accidents go down for each extra camera. The next question is interpret the y-intercept. The y-intercept in this case was 55.5. That y-intercept happens when x is equal to 0. What's x again? The number of speed cameras. So when I have 0 speed cameras, I can conclude, based on my data, that I have 55 accidents per 7 days. When there are 0 cameras, there are 55.5 accidents per week. My driving instructor told me that there's no such thing as accidents, right? Accidents mean that it wasn't supposed to happen, but whenever there's an accident, it means someone is doing something they're not supposed to. So they're actually preventable. Anyways, but when there's 0 cameras, there are 55.5. Okay, finally, we have another example. Oh, just note, the y-intercept might not always have a meaning. Let's do one more question here. A group of rowers investigates the relationship between the number of rowers in their canoe and the maximum speed. And this is the regression line they have. So they see how fast they go with 1 rower, how fast with 2, how fast with 3, how fast with 4. They plot it. So let's interpret, right? There's that key word, the slope and y-intercept. It doesn't mean what is the number, although you can list it if you like. The interpretation means tell me what it means. Well, this means that for each extra rower I add, my max speed increases by 0.45 kilometers per hour. So this is how much the max speed increases with each additional rower. And then I have my y-intercept, which is 7.4. Think about what this is. This is how fast I'm going when r is 0. So that would be how fast I'm going with 0 rowers, which is sort of impossible. If I have 0 rowers, the boat's not moving. So this is not a useful y-intercept. It has no meaning. It doesn't mean anything. It's just it's just part of my expression. Because we'll put in brackets, the boat needs rowers to move. So as you can see, this is a pretty easy topic that we've done before, the line of best fit. But these questions you should definitely focus on. Some of the tricks about a regression: you can't always use the data to make predictions if the predictions aren't appropriate, and being able to interpret the values. So for homework, we're going to focus on some of these questions. So here we go. Homework. We have page 341, number 3, 343, number 1 to 2, and some interpretation questions, 344, number 1 to 5. Good luck with that, and we will see you next time.